So, question 4. Surgical air control system consisting of a flow meter in series with two parallel subsystems, each of which has a moisture sensor and a pressure switch in series. The arrangement is illustrated in figure 4. That's the system here. The moisture sensor has a failure rate of 0.05. The failure rates for the pressure switch and flow meter are 0.01 and 0.009. Find the probability that the system will be operating in the required manner in 8 months after installation. So probability of operation. So that means reliability on certain time, which is 8 months. What you need to do is to solve the whole system to find the reliability. So from series to parallel, we have one serial system here, another one here, and let's call it 1 and 2. So then as soon as you solve this, you need to solve a parallel one. That would be this guy here. So I'm calling the parallel of 1, 2, and then you have the big one with the flow meter. So we have the moisture sensor failure rate 0.05, same here. The pressure switch is 0.01, 0.01, and here as well. The flow meter is 0.09, so 0.009. So first thing that I have to solve is the reliability over the period, over as 8 months, at the 8th month of the moisture sensor pressure switch on the subsystem 1. So the reliability of subsystem 1, now its time will be equal to exponential of t will be 8 months, so 8 months 12, because to make it year, so I have my failure rate on year, so I have 8 months out of 12 times the lambda of the moisture sensor, the failure rate of the moisture sensor, plus the failure rate or lambda of the pressure switch. So 0.05 times 0.001, which is equal to 0.991. 961. That's the reliability of this first serial system here. The reliability of the second one, it's exactly the same because I have the same components. So R2, that's a T, it's equal R1. So the 0.961. But to solve the parallel system, I need to find the unreliability. So what I'm looking for is the unreliability of the system 1 would be subsystem 1 would be 1 minus the reliability. So 1 minus 0.961, which is 39, which is the same as F2 because the system is the same. So to find, now I know the unreliability of both, and I can solve the parallel system. So the unreliability of the parallel system 1 and 2 is the unreliability of the system 1 times the unreliability of the system 2. So 0.039 times 0.039, which is equal to 0.002. Now I know the unreliability to here, everything in here. I need to solve the reliability of the whole system. So I need to find the reliability of the parallel system. The reliability 1, 2 will be 1 minus F1, 2. So 1 minus 0.002, which is 0.998. And now I have the reliability of the 4 components. I need to just find a serial system with the flow meter. So the final reliability will be the reliability we just found, the 0.098 times exponential of minus t, 8 months in a year, times the lambda of the flow meter. So it's 0.0009. That's a 9, which is equal to 0.992. So the second one would be find the probability that the system will be operating the required manner 8 months after installation if the pressure switch is removed from one of the parallel subsystems. So what we have is we have a system that has a moisture sensor. You have a pressure switch, and the flow meter. Here you have another moisture sensor. And then you have nothing. So I move the pressure switch. So what you could do, first you could consider that the system doesn't work because there's no pressure switch, so there's no control of the system. If you only have a sensor here connected here, you don't have a system. This is the only guy that does anything like a control thing. So you have in case of failure, you have the other path, one sensor and another sensor. So you assume that it won't work. So you have only these 3, which you would solve the reliability by making the exponential again times t, lambda of the moisture sensor, plus the lambda of the pressure switch, plus the lambda of the flow meter. So that will give you all the reliability of a serial system, and that will end up being 0955. The other case, if it would connect, which is the obvious kind of choice, you won't do anything else, so you have two moisture sensors in parallel and then two in series. In this case, you need to solve the unreliability of the moisture sensor, so you would have unreliability of moisture sensor would be 1 minus the reliability. Oh, sorry. No. So you have yeah, that's it. The reliability, the moisture sensor, 1 minus the reliability of the sensor. So this guy here, again, is the exponential minus t of the moisture sensor. So you find 1, then you solve for these two, which will be, so f of the subsystem will be the f of the moisture sensor on top. Oops. Times the one below. You would find the reliability of those two. So this Fs, the reliability would be 1 minus this guy here. So we have the reliability of those two, and then we solve the serial system for this with this other two. You find this one. Yeah, that's it. So what you need to know is that as you have more elements in parallel, expect to have a higher or greater reliability. So for the original system 992, with only the two moisture sensors in parallel, I have a slightly less smaller reliability. And then if I have only a serial system, I have the smaller reliability.